Hello grade 11s. Today we're going to be going over linear functions, which are your straight lines, and parabolas, which are the functions that smile and frown at you. Linear functions you started in grade 9, and parabolas you started in grade 10, but parabolas have evolved slightly through the years. Going on to linear functions. Now, linear functions started in the format of y is equals to mx plus c. This was back in grade 9, where m was your gradient and c was your y-intercept. In grade 10, we introduced the format y is equals to ax plus q, where a is your gradient and q is your y-intercept. Now the gradient is still calculated in exactly the same way, which is m is equals to y2. This means the y value from your second coordinate, and y minus y1 over x2 minus x1. If your gradient is positive, in other words, if m is more than 0, or in this case, if a is more than 0, then your line is going to be moving in an upwards direction. If your gradient is then negative, so a is less than 0, then your line will be moving in a downwards direction. Now there's a little bit more to the straight line. You can also get lines that are parallel as well as perpendicular. Now perpendicular, you remember, it meets at a 90-degree angle, whereas parallel, they run next to each other forever and never ever touch each other. Perpendicular lines will have a gradient that when they are multiplied together, you will get an answer of -1. In other words, if you take the first gradient, let's call it m1, you multiply it by the second gradient, you will get an answer of -1. Your parallel lines, let's call them again m1, will be equal to m2. Those are the basics you need to know for straight lines in order to do any problem. You're able to find the equation of a straight line through all of these characteristics, and we can move on to the parabola. Now the parabola in grade 10 had the format of y is equals to ax squared plus q. This parabola, we've practiced drawing it as a smile. And if you remember, it would be a smile when a was more than 0. We also practiced drawing it upside down, and this happened when a was less than 0. It's really important that you know how to write inequalities, because most of your questions are asked as inequalities in tests and exams. Now we also moved this along the along the y-axis up and down by changing the y-intercept of q. Q doesn't always represent the y-intercept. However, in grade 10, where there is a lack of p, Q will represent the y-intercept. Why? Because Q is the turning point. And the turning point was happening along the y-intercept. If Q was positive, it would mean that the turning point would be up on the top. As you can see, I'm drawing a parabola that has a positive a value as well. If Q is negative, it would be down at the bottom. Now, as this parabola that I'm drawing also has an a value that is negative. But we're not in grade 10 anymore, we're now in grade 11, and we deal with the formula y is equals to a x plus p squared plus q. The reason we do this new formula is because our turning point is now moving all over the place. So in grade 10, we moved the parabola only up and down. In grade 11, we can move it into any one of the quadrants by changing the q and the p value. Your turning point is defined by negative p and q. If you wanted to work out your y-intercept, you would still do the same calculations as you had done before. To calculate your y-intercept, you would make x equal to 0. And to calculate your x-intercept, you would make y equal to 0. Now, just to confuse you even further, we throw in a further formula. The further formula is y is equals to ax squared plus bx plus c. And you are able to change between this formula and the previous one by completing the square. If we go back to the board, y is equals to ax squared plus bx plus c. In this particular formula, c represents your y-intercept. B and A can be used to work out your turning point, but only the x-coordinate of your turning point. So your turning point now has a formula of x is equals to negative b over 2a. Once we've found the x-coordinate for the turning point, we would substitute that back into the formula to find out the y-coordinate and then write it as an ordered pair for an answer. If you were given the formula in this format and you weren't comfortable with finding the x and the y coordinates that way, you can find the turning point by completing the square. So let's practice quickly completing the square. Now in the formula, let's make up a formula of y is equals to x squared plus 6x plus 2. We've been given this formula, and yet you're sitting in an exam and you're not feeling comfortable with using it, so then you quickly complete the square. It's a good skill to have because you always have a completing the square problem in a paper 1 exam, so you might as well practice it with your functions as well. When completing the square, we've first got to figure out what will make the 6x. I do this by doing a trinomial. There are various ways to do it. I prefer using the trinomial method. So x squared becomes x and x. Those are two factors of x squared. Now what will make up 6 when added together? Well, 3 and 3. Now remember, when we're completing the square, we want to have our two factors exactly the same because we want a perfect square. And a perfect square is a shape that has equal sides on both sides. Going back to the board, now 3 times 3 is going to give us 9. So that is what we're going to add to this, as well as subtract it. Whatever we add to an equation, we need to subtract it as well. Now usually when you're doing equations, you would add the same number to the same side, to both sides, but we're not interested in this over here. What we really want is to change that and that over there into a perfect square of x plus 3 squared, then add 2 and negative 9, giving us negative 7. Now let's just prove quickly that this is the same formula. Let's start by multiplying out the brackets. You can do this by squaring the binomial. X squared becomes x squared. X times 3 times 2 becomes 6x, and 3 squared becomes 9. Remember, when you multiply out a binomial by a binomial, you should get 3 answers. Minus 7, and we get the same function of x squared plus 6x plus 2. Exactly the same as up there. So if you are sitting in an exam and you don't want to use the formula, or if you've forgotten the formula of how to work out the x-coordinate, you can find the turning point by first completing the square. If we look at our completed square, you'll see that our value of p is 3 and our value of q is minus 7. So that means our turning point is minus p q. So it's going to be minus 3 and minus 7. Before we move on, we need to first discuss domain and range. Now, domain and range you've been talking about for quite a while. Domain are the values that your function can be when it's traveling along the x-axis, and range are the functions that your y values can be. In the parabola, your domain, x is real for any number. We write this down using fancy symbols, x is an element of any real number. Now you can also write this as x is between negative infinity and positive infinity, but I don't know why you would want to do it, because this is far easier to do. Now let's just label it, domain. Your range is found in much the same way. However, it's a good idea to look at the function before labeling it. If we were to, say for instance, look at a function that had a positive a value, so it's going up, and had a turning point of 0 and negative 3, your function will be going up from negative 3. So the lowest point it will be negative 3, but it will be higher than or equal to that value. Now this, you've also got to state then that y is an element of any real number, just to say that it's true. You can also write it as interval notation, where you say y is an element of negative 3, sorry, that's meant to be square brackets, y is an element of negative 3 right through to infinity. The reason we use square brackets is because negative 3 is included in the set of values that y can be. If negative 3 was an asymptote, say for instance in a hyperbola, then our function would not be able to touch that point. But in a parabola, it goes right down to the turning point and then up again. Let's go to transformations. Now transformations is when we move the function all around the graph. If we wanted to move it up and down, we would change the value of the y's. And if we wanted to move it from left to right, we would change the values of the x. Let's do a few examples. If we had f of x is equals to 2x squared plus 2, and we wanted to move it down by 2 spaces. Now logic would say that we were going to minus some values. However, if we want to move it down, we need to change the y value by adding 2. So you do the opposite to what feels natural in this instance. Now we don't want the function to remain f of x plus 2 is equals to blah blah blah. We would rather take it to the other side, and now you'll see that it becomes minus 2, taking the y-intercept down to 0. So we have moved it down by adding 2 to the function. If we wanted to move the function up, we would therefore minus from the y to the f of x. Now if we're going to translate horizontally, that's from left to right, we're going to have to change the values that x are. You must be careful when you're changing the x values and the y values, because it does look very similar. If you look over here, you'll see that if we want to change the same function by moving it across, let's move it across by 2. We're going to have to change all of the x values that were over there. So it now becomes 2x plus 2 squared plus 2. So when we were working with the vertical translation, we added the 2 outside of the brackets. When we're working with the horizontal translation, we added the 2 to the x. So we add the 2 to the y when we're working with vertical translations, and we add the 2 to the x with horizontal translations. Now once again, if you are adding, you're going to move in the opposite direction that feels natural. You're going to move to the left. For those of you who can't remember which way is left, that is to the left. Let's see how it looks once we've done this. So it becomes 2x squared plus 4x. Remember, when we multiply out a binomial, we've got to get 3 terms as an answer, plus 2, multiply out the brackets, 2x squared plus 8x plus 8 plus 2, and we get a final answer of 2x squared plus 8x plus 10. So our function has now moved to a new position, 2 units to the left. If we wanted to move 2 units to the right, we would have minused from the x values. Moving on to reflections. Now reflections I like to think of in terms of transformations. If we wanted to reflect about the x-axis, remember the formula for the x-axis is y is equals to 0. So that means the rule for the transformation would be xy becomes x negative y. If we are reflecting about the x-axis, it means all of our y values are going to change. Remember, the x-axis goes across. So if the parabola was going in a frown shape, it would then swap and then smile. If our point at the top was 3, our new point at the bottom is going to be -3, and it's only the y coordinates that have changed. So in the same way, in our function, we're going to change only the y coordinates. Let's work with that same function. So we started with f of x is equals to 2x squared plus 2, and we're changing all of the y's to a negative, so we're reflecting about the x-axis. We put a negative in front, and we leave it as 2x squared plus 2. Now if we reflect along the y-axis, it means that we are reflecting from one side to the other side. The x-axis is from bottom to top, the y-axis from one side to the other side. So now we need to reflect along the y-axis, which has the formula of x is equals to 0, which means the rule in transformations is going to be xy becomes negative x y. We need to use a different example for this, because the other example will just reflect to exactly the same function. So let's say f of x is equals to x squared plus 2x plus 7. The question will ask to reflect f of x about the y-axis to the function h of x. So let's see how we do that. First, start off by renaming your function h of x. And now change all of the values of x to a negative. Ooh. Negative x squared is still x squared. 2 times negative x actually becomes negative 2. So that plus is no longer relevant. Plus 7x. Now that we've done transformations of functions, we need to cover one more step, and that is finding the equation of a parabola. Now, a parabola you can find by using 2 main equations. Firstly, if you are given the turning point, remember the turning point comes in the formula negative p and q, making it quite easy to use the formula y is equals to a x plus p squared plus q. Now remember that in the turning point, p is a negative, but in the formula, q is a positive. The other way you can do it is by using the formula y is equals to a x minus x1 and x minus x2. Okay, the x1 and the x2 don't really mean much. They're just telling us that we've got an x point, which we're calling number 1, and an x point that we're calling number 2. In this case, we're talking about the x-intercepts, where the parabola cuts the x-axis. We would use this formula to find the equation of a parabola when we have the x-intercepts and we have one extra point. With the other formula, we would use it when we have a turning point and we have one extra point. Moving on to the questions. In the first question, it says, consider the functions f of x is equals to 2x plus 4 and g of x is equals to x squared plus 2x. Now, x1 and x2 don't really mean much. What they're saying is that we've got an x point that we're calling number 1, and we've got another point which we're calling number 2. These 2 points in this case are our x-intercepts. So it's the points at which the parabola cuts through the x-axis. we would use this formula to find the equation of a parabola when we have the x-intercepts and we have an extra point. Whereas the other formula, we would need the turning point and another point to use. So you've got to know which one to use in which case. Let's see what our practice questions have for us. In question 1, it says, consider the functions f of x is equals to 2x plus 4 and g of x is equals to x squared plus 2x. Let's talk about f of x for a little while. 2x plus 4. Now the x is by itself, well, it's got a coefficient, which means that it's not squared. X is not an exponent, it's not in a denominator, there are no trig functions attached to it, so this can only be a straight line. You need to be able to identify which function it is just by looking at the formula, so it's really important that you study that. G of x has an x squared in it, and that indicates that it's a parabola. Let's look at the questions. It says determine f of negative 2. And this is what's wonderful about the functional notation, is it tells you in the question what it wants you to do. The negative 2 has replaced the x over there, which means that for every x, we're going to replace it with a negative 2. There's another x. So in our calculations, we write f of negative 2 is equals to 2 negative 2 plus 4. 2 times negative 2 is negative 4 plus 4 is equals to 0. The question asked us what values y would be when x was negative 2. It didn't say this in words, it just showed us f of negative 2, which meant we needed to substitute in negative 2 for x. And what we found is that y is equals to 0 when x is equals to negative 2. We do this whenever they replace x with anything in functional notation. Let's see what the second question is. B, it asks us to determine a if f of a is equals to 0. Now, in this case, they've replaced x with another variable, a, and they want us to work out what a is going to be. This would not be possible if they hadn't told us that f of a is equals to 0. So what are we going to do? We're going to replace all of the x's with a's, and then we're going to make that equation equal to 0 and solve for a. So over there is an x. It would become 2a plus 4 is equals to 0. At this point, you can do it one of two ways. You can either multiply it out using distributive law and get 2a plus 8, or you can divide 0 by 2 and get rid of the 2. It's the easier option to divide by it, but either way you're going to get to the same answer. So whatever your personal preference is, you follow that because that's what you'll be happy doing. I'm going to divide by 2. So the 2 over here is being multiplied by the brackets, and for that reason we can divide on the other side. 0 divided by anything is still equal to 0. And now we have a plus 4 is equals to 0, which means that a is equals to negative 4. It really is that easy. All you have to do is replace the x with the variable and make the equation equal to the number that they have said. On to the next question. In C, they've asked us x if f of x is equals to g of x. This means that they want that part of f of x made equal to that part of g of x. When we are working with functions, often what they'll do is they'll put something like this at the bottom of a question with a picture. So you'll have the graph of f of x, a straight line traveling through a parabola, and they will ask you where f of x equals g of x. Most people look at it and shrug their shoulders and move on to the next question. You, however, won't, because you know what they're asking is where the two graphs meet, which means all you've got to do is make both sides equal to each other. Let's do it algebraically. 2x plus 4 is equals to x squared plus 2x. Because it is a quadratic equation, we need to move everything over to the same side. So we have x squared plus 2 minus 2x. It becomes nothing. So you don't actually have to write it there. You can leave it out if you can see it immediately. However, I'd advise you to write as much as you can. So you have x squared. Oh, it's a minus. That becomes a minus 4. The reason it becomes a minus is because we were adding it on that side. So to get rid of it, we have to minus it from both sides. And it becomes x squared minus 4, which is a difference of 2 squares. It becomes x minus 2 and x plus 2. Therefore, x will be equal to 2, or x will be equal to negative 2. That's how we work with f of x and g of x. Let's move on to the next question. And if you remember, right in the beginning, we discussed what domain and range are. Now, domain in most cases, x can be anything, any real number. It can be negative 1, it can be negative 500, because your graphs are going to carry on going and going and going. In this case is no different. With the parabola and the straight line, both will carry on going and going and going. And if we were to draw these lines forever and ever, they would touch every value of x. So rather than writing that, we will just write x as an element of any real number. Give the domain, that means the x values of the function g. Function g is the parabola. It doesn't really make a difference because both the parabola and the straight line, it would be x as an element of any real number. In the next question, they ask for the range of the function g by first writing it in the form x plus p squared plus q. This means we're going to first have to complete the square, and we will have to look at the original equation. We did practice this at the beginning of the lesson. Let's see how much you've remembered. The original equation was x squared plus 2x. So let's start off with that. Now, as I said in the beginning, I prefer figuring out what the trinomial is going to be. I'm going to use a different color here for my calculations, because these calculations aren't shown when you do your tests. X squared, the factors of x squared are going to be x, and the factors to get to 2. Well, 1 times 1 is 1, but 1 plus 1 is 2. So that means our factors are going to be 1 and 1. X times 1 is 1x, and 1 times x is 1x. X plus x is 2x, which means that we are going to be adding 1 and subtracting 1 to complete the equation. Let's show you how it looks once we have completed it. We then write the trinomial that we want. There is the trinomial into the completed square. X plus 1 squared minus 1. So what is our turning point? There and there. That is our p value, and that is our q value. Those will define the turning points. Now, they're not looking for the turning points, they're looking for the range. The range is going to be defined by the turning point, because if a is positive, what happens to the function? It smiles. And if a is negative, in other words, below 0, it frowns. What is a? Well, a is a positive. That's where a should be, and it's a positive number. So that means our function is going to smile. What is the turning point? Let's do a little sketch. The turning point is going to be at negative 1 and negative 1. So it's going to be roughly over there, and it's going to smile. Which means our range is going to go from negative 1 up. So from negative 1 all the way up to infinity. Remember, you need to write that y is an element of any real number. Occasionally we need to state the obvious, and this would be one of the cases. You can also write it using your brackets. It does include -1, so we're going to use our square brackets, -1 and to positive infinity, curled brackets. That's the best way to determine range, is to just do a quick sketch graph and see where it goes. It is possible to do it without the sketch, but personally I don't even try it, and I've been doing maths for a very long time now. So I would go with sketch it quickly, see where it is, and then write down the range. Range and domain are meant to be easy questions, so they should be questions that you get marks for. However, you won't get marks for them if you don't study them, so it is something you need to revise constantly with all of your functions. Moving on to the next question. The next question says, determine the equation of the parabola below, giving your answer in the form y is equals to ax squared plus bx plus c. Now, it's really important that you do write down your answer in ax squared plus bx plus c, because you get marks for having it exactly that way. Let's look at what information we're given. We're given a point, 6 and 4. Now, both of those equations that we looked at before need one point and then something else. The something else was either a turning point or the x-intercepts. In this case, we have an x-intercept and an x-intercept. When we spoke about it earlier, we said that x1 would represent one value and x2 would represent another value, and this is a perfect example. In x1, we're going to make it equal to 2 because that's the first intercept. And x2 will make it equal to 5 because that's the second intercept. Let's substitute it into the formula. The formula is y is equals to a x minus x1 and x minus x2. We said this was going to be x1 and this was going to be x2, so let's substitute that in quickly. Y is equals to x minus 2 and x minus 5. At this point, you could multiply it out and then substitute later. However, I feel it is easier to first substitute, get the answers inside the brackets, and then multiply out. If you do this, then you get numbers that you multiply out rather than binomials. And monomials are so much more easier to multiply than binomials. Let's do it. Okay, it's important that you say what you're going to do. I'm going to substitute the point 6, 4. You need to remember that your 6 is your x coordinate and your 4 is your y coordinate. They're always written in alphabetical order. So instead of having a y, I'm now going to replace it with 4. And instead of having an x, I'm now going to replace it with a 6. And you'll see that there are two places to substitute an x in. Don't let this bother you. Just substitute it in and see what happens. X minus 2, you should know what that is without a calculator, is 4. And 6 minus 5 is 1. 4 times 1 is so much more easier than multiplying out x minus 2 and x plus 5. You get an answer of 4a, and 4 is equals to 4a, which of course means that a is equals to 1. Now that we've done this, we can substitute it into the equation. So we had y is equals to a x minus x1, x minus x2. We now have an a value of 1. Our x remains the same. Our x1 is 2. And our x2 is 5. We've gotten all of the variables we need. We now need to multiply it out because they wanted the answer in y is equals to ax squared plus bx plus c. So if you do get to this point and you don't go any further, you don't get full marks. Read the question carefully, follow the instructions, and you can do it. Let's multiply it out. Remember your FOIL. Your first times your first is x squared. Outside is x times negative 5, which is negative 5x. Inside is negative 2 times x, which is negative 2x. And last will be positive 10. The last step is to then add your like terms. Sorry, that's x squared. X squared minus 7x plus 10. And there we have it. We have our equation in the ax squared plus bx plus c version. Let's move on to the next question. Question 3 says, find the equation of the parabola which has a turning point of 5 and negative 6 and passes through the points 2 and 12. Give your answer in the form a x plus p squared plus q. There's quite a bit of information here. They're talking about the turning point, they've given you another point, and they've given you the formula in which they want it in. We're going to play with all of these and see what happens. Your turning point, remember, is negative p q. So let's analyze that first. Here is your turning point, 5 and 6. I'm going to rewrite it here, and underneath it, just write again, it's negative p and q. If you're like me, you'll get confused as to which goes first, whether it's x or y or p or q. Remember, alphabetical order is always king, so pq, LMNO PQ, for those of you who have to go a few letters back, will give you a clue as to which one comes first. 5 is equals to negative p. This can sometimes be confusing to people, so I'm going to write it as an equation. 5 is equals to negative p, and we're going to find out what positive p is. Well, if it's a negative over here, we want to get rid of it by multiplying both sides of the equation by a negative 1, making 5 negative 5 and p positive. So now we have the p value. We now need to make sure we know what the q value is, which is negative 6. You get marks for writing both of these pieces of information down, so don't think you're being more clever by substituting straight into the equation. It's important you show your steps, your calculations, so that other people who are looking at your work know that you know what you're talking about. Let's substitute it into the equation. Now the equation is over here. Y is equals to ax plus p squared plus q. Let's put in our p values and our q values. So y is equals to a x plus negative 5, making it minus 5 squared minus 6. Okay, because I am a maths teacher and I have taught for many years, I can see that this is not going to be a trinomial that works nicely for us. So we're going to resort back to the quadratic formula. When you are faced with finding the x-intercept and you get to this point and find you can't factorize it, then use the quadratic formula. It will be on your formula sheet. You just go and you look for it and you substitute in. Now when you use the quadratic formula, you must remember that it's using the values a, b, and c. So in the formula, y is equals to ax squared plus bx plus c. A, b, and c would be 1 and negative 10 and 7. The quadratic formula are two formulas in one. It's written as minus b plus minus, and that's what indicates that it's two formulas in one, because we're too lazy. And that's what indicates that it's two formulas in one, because we're too lazy to write one formula with a plus and another formula with a minus, so we just write them both at the same time with a plus on top of a minus. Please remember that it does indicate two formulas, meaning you will get two answers and have two intercepts. Let's go back to substitution. Minus b plus minus b squared minus 4ac, all under the square root sign, over 2a. Now we said that our a value, well, let's start with the b, seeing as it's first. Our b value is negative 10 plus minus, and once again, negative 10 squared minus a was 1. Oh, let's put the 4 in first. A was 1 and c was 7. Have we completed it? No, we're still missing out 2a at the bottom. And you'd be surprised how many people forget to put in the denominator. 2 times a was 1. Now if we want to plot this function, we have all of the important points. We have the information about the y-intercept and the information about the x-intercepts, as well as the information about the turning point. So let's plot it using the y-intercept, the x-intercept, and the turning point. Let's start by drawing a set of axes. Remember, the Cartesian plane has an x and a y axis that go on forever and ever and ever. Technically, they're meant to have arrows at the end, and you're meant to label them. The y is the one that goes up and down, just like a y goes up and down. And the x goes from left to right, just like the x goes from left to right. If we look at our information, our turning point is at 5 and negative 6. So that would be the obvious first choice. What we do have to take into account is that our y-intercept is way up at 44. So we've got to make sure that the scale is something reasonable, that will be able to fit 5 and negative 6 into it, as well as 44. With a sketch graph, it's not important to have every single coordinate labeled. You don't have to label the y-axis with 1, 2, 3, 4, 5, 6. All you have to label are the important points, the intercepts and the turning point. So let's start with the turning point and label some intercepts as well. Our turning point was 5 and negative 6, so let's make a rough estimation. 5, negative 6, it's going to be down lower than it is up. So there's a nice little dot. We'll label it 5 and negative 6. Our x-intercept was 0,76, so let's put it somewhere over here. And our y-intercept was 9.24. Now, our intercepts are going to be equally spaced from the turning point. Remember that the turning point is our line of symmetry. So if this x-intercept is over here, then our other x-intercept should be roughly over there, giving us a space of roughly 9 units between. It's important to label what those are. So this one was 9.24. 0, remember we always write the x-coordinate first and then the y-coordinate. And on this side it was 0,76. Ooh. And 0. Now that we've plotted our x-intercepts and we put the labels there, you're able to get marks. If you just put a line through an x-axis, you're not going to get any marks unless you acknowledge the value. It's very important that you acknowledge what value they go through. Let's plot the y-intercept. Now the y-intercept is going to be way, way, way up here. And this isn't to scale, but it will be way, way up there, and because we know the coordinate and we can give the coordinate, it's not the end of the world that it's not to scale. Personally, when I draw parabolas, I always start from the middle. It's just easier to get a nicer curve and then to draw up in the other direction. It's always a little tricky to draw 2 points. And there we go. This is quite a steep parabola. It's not the best looking parabola. Personally, I wouldn't take it out on a date, but it's done. We've labeled our y-intercepts, we've labeled our x-intercepts, and we've labeled our turning point. We have a general shape, and that's what you get marks for the shape, the intercepts, and the turning point. The one thing we haven't discussed at this point is where your axis of symmetry is. Your axis of symmetry with the parabola is straight through the turning point. They sometimes ask this question, so it's a good idea to write a note somewhere and keep it for when you are studying. Let's move on to the next question. Question 4. Consider the graph f of x is equals to x squared minus 5x plus 8, and g of x is equals to 2x minus 2. Once again, we're dealing with a parabola and a straight line, and you should be able to see this before you even look at the question. Why? Because the x for the f of x has an x squared. So that tells you that it's going to have two answers at the x-axis, if it goes through the x-axis, meaning that it curves either up or down. Which way does this one curve? Well, x squared is positive, meaning it's in a good mood, it's going to smile at you. Now, your g of x is just a plain x, so that's going to be a straight line. Let's go back to the question and see if we're correct. And there we go. Our f of x is giving us a good smile, and our g of x is a line. Looking at this, we can see that our gradient is positive because it's moving upwards. And if we look at the formula, 2x minus 2, what is this point over here? It is minus 2. It's very important that you're able to read the graph. And over here, or read the equation. Our y-coordinate, or our y-intercept, over there is going to be 8. This information might not be useful in this question. However, with these questions, there are a set list of questions that we'll usually ask. We'll ask what the y-intercept is, which we've just practiced doing, and what the x-intercept is, which we practiced before that. Remember, when you're looking for the y-intercept, make x equal to 0. When you're looking for the x-intercept, make y equal to 0. The other question they can ask is the turning point, and then linked to that question is then the axis of symmetry. And the last question they'll ask are, what are the points of intersections? But there are 3 different ways they can ask those questions. They can say, determine where f of x is equals to g of x. And remember, we did that back in question 1. They can also ask, determine points a and b, for instance, and then mark a and b as the points of intersection. Or they can say, determine where these functions meet. Let's see what questions they're going to ask over here. If we move down, we'll see that the question asks, determine the coordinates of a and b, the points of intersection of f and g. They've been quite kind in this question. They've told you that it's a point of intersection. Usually we don't tell you. We expect you to know that points A and point B are where the 2 graphs meet. And we expect you to know this because you can look at the picture and you can see at point A, the straight line is going through the parabola, and at point B, the straight line is going through the parabola. Let's see that this is happening. And there we go. It's point A, straight line through the parabola, and point B, straight line through the parabola. Now you'll remember in a previous question, they asked us f of x is equals to g of x, and we made the 2 sides of the equation equal. That's exactly what we're going to do over here. We're going to say x squared minus 5x plus 8 is equals to 2x minus 2. Looking at the variables that are there, we can see this is going to be a quadratic equation because it's x squared. X squared tells us that we're going to need to factorize in order to get 2 answers. So before we factorize, we first need to make the equation equal to 0. We're going to do this by moving things over. But remember, whatever we do to the one side, we need to do it to the other side. So if we've got to get a minus 2 from one side to the other side, we're adding 2 to both sides. Let's do it. I'm going to move everything over to the left-hand side, so I'm going to keep x squared minus 5x plus 8 on this side and take over 2x as well as 2 is equals to 0. I now need to add my like terms, and it becomes x squared minus 3x, I'm very sorry for those of you who spotted that mistake. It should be minus 7x and plus 10. In order to find the trinomial, we need to play around with the factors a little bit. Remember, these calculations are off to the side, somewhere where no one can see it, because it's a bit of trial and error trying to get the right combination. Eventually, once you've done enough practice, and the key word there is practice, eventually once you've done enough practice, you'll be able to see the factors more easily. And so you need to practice. Let's go back to the problem. I'm going to do my calculations in green off to the side over here. My factors are x squared and 10, so it's going to be x and x, because x times x is equals to x squared, and something times something that equals 10. Let's start with the obvious one of 2 and 5. 2 times 5 is equals to 10. Now x times 5 is equals to 5x. And 2 times x is equals to 2x. If we add them together, what's our answer? 7x. Is it the same as our middle term? The answer is no. Our middle term is minus 7x. So what can we do to make this work? Well, at the moment, 2 times 5 is equals to 10. But we can also make it negative 2 times negative 5 is equals to 10. This will give us the answer of x times negative 5 is negative 5x, and negative 2 times x is negative 2x. Negative 2x plus negative 5x gives us an answer of negative 7x, which is the middle term that we were hoping for. Now that we have our two factors for the trinomial, we need to put them into their brackets. Remember that trial and error is a method that takes time. So if you don't get it the first time, don't give up. It's something worth pursuing and getting it right. Don't give up. Okay, our brackets are now going to be x. There's our first bracket, x minus 2. And our second bracket is at the bottom, x minus 5 is equals to 0. Now each one of these factors, if either one of them were equal to 0, then the equation would be true. So let's start by making x minus 2 equal to 0, which means that x is going to equal 2. And now let's make x minus 5 equal to 0. And that means x will equal 5. At this point, we found two values. The reason we found two values is because we're looking for two coordinates, both a and b. You can go and look at your function now and decide which one's going to be a and which one's going to be b, but you can also leave it until the last step. Personally, I leave it until the last step. There are some people who will then give up halfway through or think they've gotten to the right answer over here. Remember, you've still got to find the y-coordinate for both a and b, so don't stop here. Carry on, find the y-coordinate. How are we going to find it? By substitution. We're going to substitute both 2 and 5 into the equations. And with this, it really is a personal preference. You could substitute it into the parabola and get an answer from that, or you could substitute it into the straight line and get an answer from that. Personally, I always go for the easier option. Why make your life more difficult? So I'm going to substitute both of those values into two different equations, both being the straight line, and find out what y is equals to. Let's go back to the calculations. I'm going to move a bit down, give us some more space. Now we said that x, in the previous calculation, x was equals to 2 and x was equals to 5. And I'm going to separate my page into two parts at this point and do the substitution on both sides of the page. Our formula for the straight line was g of x is equals to 2x minus 2. So I'm now going to substitute 2 in for x, which means instead of writing an x over here, I'm going to put a 2 is equals to 2, and instead of writing an x, I'm going to put another 2 and minus 2. Let's check that it's still the same. Yes, 2x minus 2, and 2, what would have been x, minus 2. Let's solve for it. 2 times 2 is 4, minus 2 is going to be 2. So that means that point of intersection is going to be x is 2 and y is 2. Let's do this one over here. Once again, I'm going to use g of x. Wherever there's an x, I'm going to put 5 in its place. So g of 5 is equals to 2. 5 minus 2. What's 2 times 5? That's right, it's 10. Minus 2 is going to give us an answer of 8. Now we're going to use this 8 and this 2 to make our coordinate, this 8 and this 5 to make our coordinate of 5, 8. Remember, your x always goes first and your y last. Our last step is to determine which one is a and which one is b, and you can only do this by looking at the function and deciding which one suits which better. Let's look at that picture again. Now a was lower than b, which means the y value for a is going to be a lower value than the y value for b. Let's look at the two. The y value for a is 2, the y value is 2 over here, and the y value over here is 8. So 2 is lower than 8, meaning that a is going to be 2, 2, and b is going to be 5, 8. Well, that's it for the questions. Remember, when you do these things, you need to know how to work out your y-intercepts, your x-intercepts, and your turning points. You must also remember to study your domain and your range and your axis of symmetry. And remember how to transform your graphs to move them vertically and horizontally, that's left to right and up and down, as well as to reflect them about the different axes. Now, unfortunately, there is no substitute for practice, so the only way you're going to get this right is to practice old exam questions. Find difficult questions and do them over and over again until you get them right. It does pay off. You can do this, and you will do well. Good luck, grade 11s. Goodbye.